Good morning, students. I am Nidhi S. Bagalwadi, your science teacher, Sankalp Learning Solutions. Today, we are going to learn a new concept about chemistry. So, in the last class, we discussed regarding chemical reactions and equations, and also the reactions which we face in our daily life, which we will use in our daily life. That also we learned in the last class. Today, we are going to discuss a lot more about the chemistry which we are using in our daily life. So as I said, let us consider a lemon, let us consider turmeric. So whenever you taste certain substances, you will get sore. Whenever you touch the bleaching powder, or you can say the washing soda, the baking soda, or the soap, so you feel soapy. I hope you got the concept which I am going to discuss now, right? Did you get? We are talking about sour and bitter, then which concept it may be? Yes, guys, you are right. Your guess is right. It is acids, bases, and salts. So, in seventh standard or in our lower classes, we learned regarding the physical properties of acids, bases, and salt. Physical properties means we can say the taste, the color, how they look, and what are their actual, what we can say, sense. Like, for example, it burns. Acid burns while bases feels soapy, like that. Physical characters we learned. But in 10th standard, we are going to learn in depth regarding the chemical properties of acids as well as bases. Okay, it is a very a short concept, like we can finish it off very soon, but very interesting concept too. And we are going to demonstrate certain activities in it. So here, as I said, acids, bases, and salt, let me clear the title first. Acids. As I said, acids. We know that acids are sour in taste. They are burning in sensation, means they burn the skin, burning in their action, we can say. And they convert, when you see the litmus paper, we know that the litmus paper or the indicators are the substances which says a substance given to you is an acid or a base. So like that, many indicators we have, like pH paper, we have natural indicators like hibiscus juice, cabbage juice, as well as our turmeric powder acts also as an indicator. So indicators are nothing but which tell us that this substance is an acid or this substance is a base. And guys, we have many chemical indicators also, like phenolphthalein, methylene blue. I will just show you how the indicators look. See, this is a phenolphthalein indicator. Okay, this is a phenolphthalein indicator. Now, let us see. I took a hydrochloric acid. I took a hydrochloric. It is a dilute hydrochloric acid. You can see. Okay, dilute hydrochloric acid. So now I am taking hydrochloric acid. Okay, uh, in a test tube. So the test tube will be having the capacity of around, we can say, 10 ml. Each test tube will be having a capacity around 10 ml. So let me take, or let me just wipe out the test tube, because water should not be there. Actually, I washed the test tubes right now, just now. So I'm adding a certain amount of hydrochloric acid, and be careful while using the acids. We have to usually use the dropper. Okay, as it is on the other table, I can't stand and go ahead there. So, and we have to put the acids on the walls, that is on the walls of the tube. Whether it is concentrated or dilute, try to put the acid on the walls of a tube, not directly from here. Suppose the drop may fell on your skin or something happens. So for the precaution, we have to put the acid on the walls of the tube. So I took a hydrochloric acid. As you can see, it is a colorless. And now I am going to add a phenolphthalein indicator to it. So this is a phenolphthalein indicator, right? So this phenolphthalein indicator, I am going to add to a acid. Fine. See the color change. It turned into milky white. So let me add. So this has now hydrochloric acid, and we can say the indicator, that is phenolphthalein indicator. Now let me add sodium hydroxide to it. Sodium hydroxide. I think, yes, this is a sodium hydroxide we have. Okay, so I'm going to add a certain amount of sodium hydroxide. We know that sodium hydroxide is nothing but a base. See the color change when you are adding the sodium hydroxide. See, yes. So this indicates that whenever you add phenolphthalein to the hydrochloric acid, it turned milky white. Whenever you are adding what we can say the base, okay, that is sodium hydroxide, it is giving pink color. So this is shows that a substance which we are using, it will tell us whether a substance is an acid or a base. So now phenolphthalein acts as an indicator which shows whether a substance is an acid or base. So let us first ramp up the things before going to the next concept, right? Yeah. Now, so I hope the indicator thing is clear, and you can also experiment it at your home using the turmeric powder, just to put on the waste cloth, which is not fit for you now. So just to put a turmeric paste on it and wash with soap. You can see the pink color. Okay, that turmeric acts also as a indicator. Fine. Now, let us go to the other concept. Acids, we got to know, and acids will be having, or these are the substances which give H plus ions, that is hydrogen ions in the aqueous solution. What do you mean by aqueous solution? When acid will be dissolved in a water, then it is called aqueous solution. So the acids usually gives H plus or hydrogen ions in the water. Similarly, when we go to the bases, these are bitter in taste, soapy in nature, as well as these will give OH minus ions, that is hydroxyl ions in aqueous solution. So let us discuss regarding this concept in detail through the PPT. I hope the screen is visible for everyone. Just a minute. Fine. So, okay. As I defined the acids, the examples of acids are here, guys. The examples of acids. Acids are of two types actually. The first one is an organic acid, what we can call. So the organic acids are acids which are derived from the living organisms. Okay, these are derived from the living organisms. And here these are acetic acid, we can say vinegar, which they will use in the fast foods, and citric acid, which we will get from lemon, we can say, and lactic acid we will get it in milk and curd. Then tartaric acid we will get it in turmeric. Like that, we have many organic acids which we are using in our daily life. Next, just a minute. Fine. Next, acid can also be defined as a chemical compound which has a sour taste and whose pH value is less than 1. What is pH? We will learn in this concept itself later. Fine. Then we have one more type of acids which is called mineral acids, which are prepared in an industry or a lab. So we have many examples for mineral acids like hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid. So these all acids, whenever they dissolved in a water, okay, so they will give H plus ions. Okay, so that is why acids are the substances which gives H plus ions, we can see. Next, the next one is a bases. Okay, and examples of bases we know: sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide. Then we have the salts. Salts are the nothing but the compounds which are formed when acids reacts with bases. These are usually neutral in nature. And we also heard the term like strong acids, strong bases, weak acids, weak bases, like that. So what do you mean by strong acids is nothing but, as I said, the acids will give H plus ions in aqueous solution. So the acids which give more number of H plus ions, then they are called as strong acids. The acids which will give less number of hydrogen ions. For example, if you took 100 ml of citric acid or acetic acid, you will get around 5 to 10 ml of H plus ions. So compared to the acid, the H plus ions amount is less. So such acids are called as weak acids. Similarly, for bases, the bases which will give more OH minus ions in aqueous solution, more OH minus ions in aqueous solution. So certain such bases are called strong bases. The bases which will give less OH minus ion, such bases are called weak bases. Okay. Now let us move to the chemical properties of acids. The first chemical property is, how do acids and bases react with the metals? React with the metals. Metals we know, example copper, iron, zinc, aluminum. So these all are the examples of the metal. So when these metals react with certain acids, what are the products formed? So as you can see, the general formed over here, acid and base when they react, acid or base when they react with the metal, the products formed are salt and hydrogen gas. Now you can ask me how we will get to know it is a hydrogen gas. Salt is formed which will be soluble in a solution, you can't see it. But hydrogen gas, how we will say it is a hydrogen gas only? It is by a pop sound. When we will be doing the experiment, we will get a pop sound. When we take a burning matchstick near that test tube, we will get the pop sound. Or you can say during Diwali, if you are cracking the crackers, so what happens if you're burning the crackers, in that we will use that sursur batti, right? The small one, the small children will use. So how that sound will come? No, like that sound will come when hydrogen gas is released. It is called pop sound. So such reaction occurs when acids react with the metals. So which gas is released? Hydrogen gas is released. We have example like zinc. So when zinc reacts with a sulfuric acid, we will get a salt of a zinc, that is nothing but a zinc sulfate, which is salt. It will be soluble in aqueous solution. It will be dissolved in aqueous solution. That is why you can't see it. Then the hydrogen gas. Similarly, when zinc reacts with a base like sodium hydroxide, the salt is formed which is called sodium zincate. The salt is sodium zincate, which will be soluble in water. So it will be in the form of aqueous solution and with the liberation of hydrogen gas. So both acid and base, when they react with the metal, the products formed are salt and hydrogen gas. Regarding the activity, we will be going to discuss in the next session. Next, we have reaction of zinc metal with dilute sulfuric acid, the activity given in the textbook. For that, you need a stand, you need a test tube, we need dilute sulfuric acid and zinc granules. I will show you how zinc granules look in the next session. So we have to take all these things and put a rubber cork, and to that cork attach a delivery tube, which will be made up of glass. That the other end of delivery tube should be kept in a vessel which is containing soap solution. Fine. Then after that, when you put a zinc in the sulfuric acid, the bubbles occur. These bubbles are nothing but the hydrogen gas. So this hydrogen gas, as it is in the form of a gaseous, as it is in a gaseous form, it will rise up and it will go to the delivery tube. In the delivery tube, near the delivery tube, if you take a lighted candle, so you will get a pop sound with the burning of that candle. Okay, so that is nothing but the release of hydrogen gas. Next, we have the reaction, that is how do acid reacts with metal carbonate. So what are metal carbonates? Metal carbonates are when the metal reacts with the carbonic acid, we will get the metal carbonates or the compounds. So when these metal carbonates reacts with the acids, we will get the products like salt, carbon dioxide and water. When acid reacted with metal, we got salt and hydrogen gas. When acid react with metal carbonate, we will get salt, carbon dioxide and water. Now you will ask me how we will get to know how the gas released is carbon dioxide. For that, we have to consider a test tube. So let us take, we can say sodium carbonate in a test tube, and we are adding sodium carbonate is a metal. Metal is a sodium carbonate. So it is a metal carbonate. When we add hydrochloric acid to it, you will get the effervescence. Effervescence means if you are, when you are drinking the carbonated drinks like Pepsi, Coca-Cola, Mountain Dew, etc. When you open the top of it, okay, so you will get that foam like, that is nothing but the carbon dioxide gas. So like that only you will get when you perform this activity, when sodium carbonate reacts with hydrochloric acid. Again, to confirm it, what happens, we have to attach the delivery tube through the test tube. So the carbon dioxide released, okay, the carbon dioxide released, it will be rise up and comes to the delivery tube, and at the other end of delivery tube we should take a test tube with calcium hydroxide. We should take a test tube with calcium hydroxide. So that calcium hydroxide turns milky once the carbon dioxide reacts with it. So it confirms that carbon dioxide gas is released during the reaction. So this is regarding the reaction of acids with metal carbonates. Okay. Now, similarly, when acid and base react with one another, we will get the products like salt and water. We will get the products like salt and water. This salt will be having certain charged particles which are cations and anions. Okay. Now, so this is regarding certain reactions in acids and bases. In the next session, we are going to learn two more reactions regarding acids and bases, and we are going to learn a lot about the uses of pH in our daily life. Okay. Until that, take care. Have a nice day. Bye-bye.